G'day guys. Actually, I just quickly found out what it was. I had a look and found that the BC 857, which lives, I hope I don't stick my head too far into it, which lives right there. I got just underneath the point of the tweezers, actually failed. It actually went short. And it actually, when it goes short circuit, it's quite good if it goes base emitter short, because it holds the voltage off the gate on these, and otherwise these would be in limbo, not conducting properly or somewhere in between, and the flyback would just blow these up again, so I'd have to replace them again. So I have flicked out the 857. I have a new one here, which is that one, and I'm just going to stick that in there. Then I'm going to turn it on, just prove a point that that's all that's wrong with it. So one BC 857. And if you want to be pedantic about these, get the low noise one, which is a C. Now, so I can't grab it. There we go. Get on there. I don't care if you're up in the air a bit. It'd be better for heat sinking. But I'll squash it down a bit. And the other side of this goes to the 15-volt rail. I have discharged that capacitor. If I didn't, it will blow up. It will not function. And oh, there's that good solder. By the way, the best solder I've used is this Duratec stuff, right? I bought all these rolls of solder here and there. It all says it's 60, 40, this, that, and the other. You need a blowtorch to melt that. It won't melt at normal temperatures. I don't know what's wrong with Chinese solder. It is, well, it says made in China, but this stuff melts beautifully. And these are all tin lead solders, and they just, I don't know, it's got something else in there. It doesn't work properly. Let's clean that up a bit. That looks all right. Okay, proof of the pudding. We'll put it coil back on. Yeah, it took me all of about 2 minutes to find that. I should have left the video rolling, but I thought it might have been more involved. If it was going to involve the ADG 333, that would have been a big job. So even now it works, or smoke billows out. Yay, it's a worker. Nice and quiet too, isn't it? It's on a mono. And that sounds all right, doesn't it? Except someone's got the tone all the way up. There we go. It's in normal. Tracking sensitive, all metal. So that's on my good coil I made too, by the way. Every detector I've put on this coil so far has sounded really quiet in mono mode. I did a 4000 before, and it was absolutely quiet. And it was sensitive as, but I don't know. You tell me. So anyway, we'll get a 0.1. Did you know I just tracked out a 0.1? Did you hear that? It tracked it out. I don't know how that could possibly happen. No way. Hang on a second. No, it's a mono, sensitive, all metal. It's in tracking. You can't track out a gold nugget. No way. It's sounding a little bit too quiet now. Something else might be up the creek. I'll try a bigger target. Oh no. Oh no, it's having a hernia. It's lost its mojo. Something else is wrong. So I've got to get in. Even though I got it working, something else spat the dummy. not the input FETs, they're cold. Well, they're slightly warm, which I'd expect. That maybe the other op amp got damaged and it was just on its way out. And the other one went down first and pulled the supply down. Something like that. Look, bloody, it's electronics, isn't it? It's electronics. It's going to drive you bonkers. But it did start off okay. And then it lost its mojo. So we've got to get its mojo back. What happened? What happened? Nothing's hot. That's just weird. That's too weird for my liking. Unless the power stage has died. I better check that with the meter while I'm here. I just got to check everything, just make sure that I'm not barking up the wrong tree. Let's have a look. It's on. Make sure the coil wires haven't fallen off. Sometimes that does happen. It's like it's in cancel mode. I'll put in double D. Mono. There's something else. I think the other op amp's dead. Yeah, the other op amp's dead because I've got it in cancel mode now, and that means it's working on one op amp and not the other. So we could prove that out because I've got a mono on it. We'll just put this. I'll just set this up looking at the oscilloscope, and I'll just go and reroute this a little bit over. Now where am I going? Oh God, that way. Talk about going the wrong direction. Okay, I'll see if I can make that zoom in a bit. Okay, I'll just have a look at the op amp inputs, and we'll see. One of them will have possibly decent input going in, and the other one won't, or something of that nature. But first of all, just have a look at the transmit waveform. I'll just turn the poor old oscilloscope. Oh, look at the cables everywhere. Just okay. Okay, we've got our 15, the three small 15-volt pulses, and the one long 5. They're the 15s. That's our 5. So all that's there and alive. The transmitter's working fine. So it's not an issue with the transmitter. So let's go on our painted ground point there. And I just have a look at the inputs of the op amps. So I'll just look at the non-inverting inputs. Pin 2. And I hope I don't kick over the stand. Okay, I've got to be careful here because it's very touchy. Okay. Well, the inputs of the op amps look okay. Well, hang on a second. I'm going to give this a bit of grunt in the light department. I just a hold off. What have I got the coupling on? Now we go low frequency. Drop the level around. There we go. Okay, that's a little bit high. We've got a bit of a DC offset there. Hang on, just make sure. I'll just flick this into ground. Yes. Okay. It's a bit jittery. Go on, behave. Oh, something there is not right. You can see it bouncing up and down. It looks okay, but it's not quite right. I'll just check the other op amp. That's the one I replaced. Aha, that's interesting. If you have a look at that, I don't know why it's jittering around. I'll find out what's going on there. Could be a lock problem. Actually, I think it might be. Hang on. I wonder if it's the input FET. I've yet to replace that, so I'll just short that out, and we'll see what happens. Just jam a screwdriver across it, because I said it might be on its way out. Makes no difference. There's something going on there. Bounce, bounce, stop. Bounce, bounce, stop. Bounce, bounce, stop. So yeah, I'll track that down too. I think it's must be something to do in the power supply somewhere, something to do with regulation. But the interesting thing is the channel that blew up. Yeah, we now you got to remember I'm not on double D coil, so that should be exactly the same as the channel I just looked at, and it is not. That's the input to the op amp. It's exactly the same as the other. It's exactly the same. Just checking the ground on that op amp. The new one I put in. The ground connection, should I say, non-inverting. It's the same. Okay. It's very strange. I just got a different. It's such a big offset there. That's very interesting. So I've got to work out why I've got such a large offset, DC offset on that device. It could be the BF 908 is not soldered properly in. I will just go over it all again and just make sure. There's something not quite right because to have a DC offset like that, that's pretty serious. I have to get where's my really good solder? I don't want to mistakenly use that um, stuff what I got from China. It is just NQR, that stuff. So I don't know why we've got this massive offset. Should have turned the camera down. You can watch me splot solder everywhere. Okay, there, that. I'm redoing the whole everything here, just in case. Yeah, dear. Damn it. Made a solder bridge. Getting a bit too carried away with the flow of the solder and made a bridge. I'm looking for look on the bench. My God, I'm looking for either a sucker or something. Actually, can't see it. What I just use a blade, and I'll just unstick it with a blade and separate it, and then redo it. I have all these little tricks. Hopefully, I can get in there. Yeah, get in there. There you go. Fix that. Use a blade. As soon as I said that, I went and touched the iron and did the same thing again. Oh, God. Okay. Okay, that is separated. But I love electronics. It's fantastic. It really is. Okay. The trouble is, I'm using a a tip that's probably a little bit too big for doing this. There, there. I'll just do that. Yeah. That BF 908 again. Everything looks fine. But that offset, why? Why do we have an offset like that? Okay. I've given it the treatment. We'll just see if that offset's still there. That's really strange. Oh, look at that. Ah, she's oscillating. Why? What? I'm on the between the two diodes. No, see, it's doing a high frequency oscillation. Now it's only happened after I gave it a touch of the iron. So what is going on there? I had it in cancel mode too. I'll get it out of cancel mode, fire it up again. Gotta be careful. Yeah, something's up the creek for sure. Something's not quite right, and it doesn't look like it's in the power MOSFET or the larger MOSFET. I shouldn't say power; they're only rated at 1 amp. Have I got a dicky op amp? Something funny's going on. Let's give everything a touch up again. There's a few components here that wouldn't care less if it was there or not. I mean, protection diodes and things like that. But yeah, strange. Okay, everything's definitely soldered up properly. No dry joints. So I just can't work out why that was oscillating. It wasn't before. What have I got now? Well, that doesn't look very healthy. So it's 2 volts negative out of the op amp. That's what it should look like. Making a lot of noise. I think the op amp's died. That's compensation pins I'm looking at the moment. Now I'm just touching the top of that op amp with the oscilloscope probe, and it's actually making a noise. There's something funny going on here. I've got my finger on it. I've got my finger on that op amp. I'm using a 0.1. Hang on a second. This is very strange. I might have a really dicky op amp I've just put in this. Okay. I have absolutely no idea why that's doing that. It has supply rail. It has, just make sure what I put in there. Yeah, it's correct. That's really strange. I don't understand why that would happen. What I'll do, yeah, look at the oscilloscope screen. Saying low battery. Okay. So what we do, I will put another device in there. So you can, I think you can see there. It's behind the damn two big capacitors. But the way I've got to do this is the way I've got to do it. Let me have a look. I'll go in my drawer of AD797s. Come here, you. These are damn expensive, but if you want your detector to run good, you could put anything in there and hopefully it would work. So actually, that's an AD I've rescued from another detector. What I'll do just to get this off, I'll just flood it with solder and just heat it up. It should pop off really quick. Well, hopefully it pops off quickly. Yeah, the other channel's working beautifully, but in mono, it parallels both channels together, and you can't operate the detector with one good and one bad. So we'll just take him out, swap him. Oh, I don't know how that even died. I got no idea. Or was it faulty to start with? Here we go. Off you go. You be careful flicking it like this too. If you flick it and the solder dries and hangs on to the legs on the pads, the legs hang to the pads. It will pull the pads off. So there is our op amp for big solder blob on it, which I did, of course. And I'll put a new one. I'll put another one in there. A known good reclaimed. So that's that. That's that. I was checking. I was gonna. All these detectors have a huge amount of white paint, and when it gets hot, it bubbles up, makes it hard to get on the pads properly. What I want to do, okay, I'll get this little AD797. Come here, you expensive audio chip. That's what we'll call it. Work really good for detectors though. It's because they're very low noise, and they are very stable and well behaved. At a gain over 3, by the way, for these. If you try and do a unity gain buffer or something, it'll just oscillate. So I don't know. It wasn't being used in that function, so I don't know what's going on. Okay. I am just going to stick my head in there and line him up and stick him on. So there we go. There. Okay. There. There. And there. Okay. We'll put a new one in there. We'll see what happens. I suppose you probably want to look at the oscilloscope screen. Where I'm flying blind here. I'll put it back on the oscilloscope screen just so you will see what's going on. There we go. Lift that up. somewhere there. Okay, fingers crossed. It's nothing going up its inputs, because I checked that. If it had a big lot of DC going up there, I wouldn't have put a new op amp in there. So just maybe the other one was dicky. So I'll go on the output of this op amp and I'll flick it on, and look at that. It was a dicky op amp. So that's on 1 volt, but we've got a center line there now. I'm pretty sure both are the same. Not much amplitude coming out of this. What have I got set on? Mono. It's actually, it looks correct. I'll just take the... Still got that, whatever that could be 50 hertz actually. Oh, hang on, I know what it is. I know what it is. It's a power supply pulling on the screen. If I turn that off, it goes away. Okay. Why is it so quiet? Okay, we still got some problem somewhere. I've got the correct waveforms, but we've got nothing coming out. What's going on? So it's not the op amps. It's This gets interesting, doesn't it? Let's check all the input wires, make sure they're on the plug. Nothing funny's going on there. We got that there, that there, that there. All connected. What's going on? Sounds good. I'm going to put it back into double D. Just see if we get a signal. Weak. It's so weak. Mono. All metal. Okay. It works in double D. And now I flicked it into mono, and now it's working. I think I've got a dicky switch. Something funny's going on here. Hang on, there we go. That was double D. And this is cancel. Should absolutely be dead quiet. Okay, it's dead quiet and cancel for mono on it, of course. Yep, and we'll go back into... Okay. 0.1. Sounds like it's working to me. What I'll do, I'm going to hook up the oscilloscope probe on that funny channel, and I'm going to put some big heavy metal on the coil. Okay, there's our signal. I'll get a screwdriver and put it across the coil. Okay, it's doing exactly what it's meant to do. Now I'm on the other op amp. Yeah. Let's turn that down, it's a bit noisy. But I've got on both outputs of the op amps, and that's our correct waveform we want to see. Aha. Okay, what's happening is I'm putting this into sensitive. It wasn't in normal, it wasn't in just mono, it's in sensitive. And in sensitive, it dies. So we've got a speed problem somewhere, I'd say. What do we got on here? We got deep, there's nothing there. Look, it could be a switch problem. When I put into sensitive, I get no audio. Why? No, something else is going on. Well, in sensitive mode, I'm going to have to go and chase that, find out where it goes. That I think that gives a control line to it to the EEPROM here for memory. I don't know what's going on. I'll have to go and find that. What a bugger! So I've got it fixed, but we've still got a small problem. It sounds like it's well, the way it sounds like to me is like the transmitter's ramming up the receiver and totally desensitizing it, but it's not. If you look at the oscilloscope waveform, that's not happening. So it's something in the DMOD. It might be the 4051 chip. That's the only thing I can think of because that's what it controls. So what I might do, I'll poke around the 4051. I'm not going to keep doing video on this unless, you know, look, if you want to see a complete repair from a blown up detector start to finish, I could do it one day, just have it running as a live feed. But it might be too boring. I don't know. You tell me. But if we go into normal, well, actually not sensitive, but just normal timings, and, yeah, it works. So that's a bit of a strange one, isn't it? So I've got one mode. Yeah, I've got one mode that doesn't work. It could be anything. It could even be just a broken wire or something. I don't know. I'll hunt around. I'll see where it goes. I'll track it down. If it goes to the 4051, I will just replace that chip. And let's hope it's not anything more complicated because then I'm going to dig a lot harder. I like it when it's fairly easy. So how's that? We've had the both input N-channel MOSFETs blown up. We've had a BAV99 sitting around there blown up. We've had the BC857 blown up, which wasn't at first, but it just died. I think everything got a bit cooked. Then we've had an op amp that was blown up. Then we've had an op amp put in with a massive DC offset for some reason. Yeah, so it was all going a bit pear-shaped. Had to replace that BF908. That was cooked. That was burnt in the middle. BAV99. The P-channel devices, which I think, for memory, I put in some 3407 FETs. Yeah, maybe possibly, they might have a little bit too much capacitance. I don't know. They've got very low on resistance. I'll just investigate that. But no, the waveform's fine. Yeah, it's I'll clock it down in frequency and see if the sensitive mode comes up. Then it'll tell me that I've got a capacitance problem in something or other sitting on the board. But apart from that, yeah, I'll work it out. It's no big deal. This guy was busted for his detector too. He goes, it went up in smoke and they're out detecting. So it's one of those click your fingers and fix it now type jobs, but nothing happens that fast. Yeah, anyway, leave it there. Catches.